our lesson. Today we shall look at work, power and energy. What is work? Work is defined as the product of force and the distance moved in the direction of force. And that means that work is done when a force is applied on the body and that body moves in the direction of force. And from the definition, therefore, work equals to force times the distance traveled in the direction of force. And this is measured in joules. A joule is the work done when a force of 1 Newton moves a body through a distance of 1 meter in the direction of force. We have other units apart from joule. We have the kilojoules, we have the megajoules, among others. But 1 kilojoule is equivalent to 1,000 joules, and where 1 megajoule is equivalent to 1 million joules. So from the formula for work, we can look at some examples. Our example 1 says a body of mass is lifted through a distance of 6 meters, and we are supposed to calculate the work done. But we've seen that the work done equals to force times the distance traveled in the direction of force. Therefore, for us to be able to find the work done, we must first of all find force and also get the distance. But in the question, we are given the mass of the body. So using the mass of the body, we can find the force. That is, force is mass times the acceleration due to gravity. So force is equivalent to the weight of the body, and that is 50 newtons. So after getting the force and we are given the distance, we can now get the work done. So the work done will be 50 times 6 to give us 300 joules. In example 2, we are told to calculate the work done when a force of 30 newtons moves through a distance of 9 centimeters. So this time round we are given the force, but if you look at the distance we are given, the distance is in centimeters, which requires us to first change to meters, because we must carry out calculations using the SI units. So we shall change the 9 centimeters to meters by dividing by 100, and that's why we are given in the solution that work done equals to force times the distance, which is the 30 newtons times 0.09, implying that they divided the 9 centimeters by 100 to change it to meters, which gives us the final answer as 2.7 joules. Then in our example 3, we are told that a man climbs a hill that is 300 meters high. If his weight is 50 kilograms. Then we are supposed to find the work he does to lift his body to the top of the hill. So we are given the distance and we are given the mass, meaning that we need to first find the force of this man. So the force is mass times the acceleration due to gravity, which is 500 newtons. After getting the force, that is 500 newtons, we shall now substitute in our formula for finding the work done. That is force times distance, which is the 500 newtons times the 300 meters, to give us 150,000 joules as the work done. So that is what we can discuss about work. What we need to know about work is we must know the definition of work, and we've seen that it is the product of force and the distance moved in the direction of force. 2. We must know the SI unit of work. We've said that the SI unit of work is joule, and we defined a joule as the work done when a force of 1 Newton acts on a body to move through a distance of 1 meter in the direction of force. After that, we looked at the formula for finding work done, which is force times distance. And now we look at how we can work out some problems requiring us to find work done. That is what we need to know about work. We can now look at energy. We are defining energy as the ability to do work, or the capacity to do work. And the SI unit of energy is still joule. We look at sources of energy. We have various sources of energy, among which includes the following: the sun or the solar energy. We can collect solar energy from the sun, which can be converted into other forms of energy that could be useful to man in various ways. We have the chemical energy obtained from food, fuel, among others. Yes, from food, the body gets chemical energy. We can also get chemical energy from fuel. We also have the heat energy that is obtained from fuel. We have also electric heaters and radiations from the sun. These all provide us with heat energy. We have light energy that is obtained from conversion of other forms of energy. We can convert other forms of energy to light by help of some devices. We also have electric energy that is obtained from running water, dynamos, and generators. We have nuclear energy that is obtained from nuclear reactions. It could be nuclear fusion or nuclear fission. We have mechanical energy that is obtained from conversion of other forms of energy. Yes, we can convert electrical to mechanical. using special devices. And therefore, the main sources of energy are 1. Food, 2. Fuel. When we talk about fuel, we can mean gas, paraffin, coal, among others. We also have wind as a source of energy. We have sun, we have running water. So those are some of the main sources of energy. So we shall look at the one form, that is mechanical energy. Mechanical energy can be divided into two. That is the potential energy and the kinetic energy. So we shall look at these two in particular. Let us start with kinetic energy. We are given kinetic energy as the energy possessed by a body in motion. For instance, we have running water. Running water have kinetic energy. We have moving braids. Anything that is in motion possesses kinetic energy, and kinetic energy is measured in joules. Kinetic energy is determined by the help of a formula, that is kinetic energy equals to a half mass times velocity squared. And from this formula we can look at some examples of how to find kinetic energy. Number 1 says find the kinetic energy of a body of mass 2 kilograms moving with a speed of 4 meters per second. We know that kinetic energy equals to a half mv squared. So we shall substitute for mass m and speed v. If we substitute, we shall end up with the kinetic energy equaling to 4 squared, which is 16 joules. Then in our example 2, we are given one pass of mass 60 kilograms is running at a speed of 10 meters per second, and we are supposed to find his kinetic energy. Still, we shall use the help of the formula, that is a half mv squared, and substitute for m and v to get Van Persie's kinetic energy as 3000 joules. Number 3 says Evra has a mass of 50 kilograms moving with kinetic energy of 3125 joules. We are supposed to calculate the speed this time round. So we are given the mass and kinetic energy, and we are supposed to find the velocity. So we substitute for what we are given and simplify to get the speed. In our next meeting, we shall be looking at the potential energy.